In our previous class, we saw why ACI and the class design, the class architecture, which is used in ACI for effective improved data set. Now, talking about this class design, the leaf and leaf will not be connected. Likewise, spine and spine will not be connected. Spine, all spines connect to leaf, and leaf connects to spine as well as to the different domains like VMM domain, physical domain, layer 2, layer 3 domain, as well as the controller APIs. Now, before talking about those domains, let's learn something about the components that makes ACI. We have a controller called APIC. What does APIC stands for? Application, policy, infrastructure, controller. Now, this is the management plane, and this is the control plane of this entire ACI fabric. So if you take a human body, every action that human body does is all because of the brain. But do you see any brain? No. You see only hand moving, mouth talking, leg moving, body turning. But now I'm talking to you using my vocal cord, using my mouth. But actually from where these all starts? From my brain. But no one see the brain, they see only the mouth that speaks. APIC is also like a brain. For the entire ACI fabric, for every single operations in ACI fabric, APIC is the main reason. We do the configuration on this APIC, and whenever the devices are getting connected to the ACI fabric, APIC pushes the configurations to all devices. So, like a brain giving commands to all the organs of the body. When there is a fire, a big fire coming towards me, I run fast. My hands are moving, my legs are moving, my entire body is pushing opposite direction away from the fire. My entire body is being given command to escape from the fire. Likewise, APIC is the one which is going to push all configurations that are necessary for all the devices to do the task that the administrator needs. But APIC is neither comes in the path of the data flow. APIC is not a switch to which the end device is connected. Just stays away from the data plane. Same like these are all idea copied from the human body. They saw the bird, they invented airplane. Likewise, they've seen the human body and they have come up with all these ideas: APIC, ACI, SD-WAN. The hands and the legs and every organ of the body, though they are connected to the brain, but the brain is not coming in between when you do some work. It's the hands and fingers that does the work. And if someone wants to beat, they don't beat your brain, they beat your hand and leg because you beat them, they beat you. They beat your body, they beat your hand, they beat your leg. But actually, everything comes from where? The brain. Likewise, if any data need to be sent, it's not sent to APIC. The end device sends to leaf. When leaf receives the data, APIC has already told the leaf what need to be done with the packet that comes in. Fine. More about it, we'll talk about it later. Now, APIC is the brain of the ACI fabric. Now, this is very important. APIC is very important. Without APIC, you cannot configure ACI. So, APIC comes in a cluster. APIC is a cluster of 3. So even with one APIC, you can have you can have ACI, but it is always recommended to have a cluster. In a lab environment, you may see only one APIC, but in reality, if you see, there will be at least 3, sometimes even 5. So it works in the group. This never participates in the data plane. Then why I need 3 APIC? Is it not costly? Of course it is costly. This is not going to participate in the data plane. What is data plane? The plane that forwards the packet to the destination. The packet that enters in leaf 1 may leave on leaf 5. That path is what data plane is. According to what the control plane has dictated, the data plane is going to control the flow of data. As I said, APIC is not a leaf or a spine. APIC is just a controller. Then why I need to have 3 APIC? We all human being has got only one brain, in which there is 2 sections, left brain, right brain, so on. But this is God creation, left brain, right brain. APIC is not. It's It's a human developed brain. No? APIC is not that super brain like human brain. So it needs redundancy. There is need for a cluster. Now this APIC comes in both physical as well as virtual. APIC, when it comes in physical, it comes with the Cisco C series. So the Cisco C series server is not running any Windows operating system there. Instead, it has got an ACI code. Yeah, it has got the ACI operating system, ACI code. It's Cisco C series server with ACI operating system in it. That's how it is sold, physical ACI. As I said, we also have virtual ACI, virtual appliance. Now, whether you have a physical ACI EPIC or a physical EPIC or virtual EPIC, they both need to be connected. EPIC need to be connected to the leaf switches. Leaf switch will have EPIC connecting. We cannot connect to wherever we want. It's only to the leaf. Instead of me drawing a diagram, let me take one nice picture from Google. So if you see here, the leaf has got the EPIC connected. EPICs are connected only to leaf. And these are controllers. Users are connected here, you see. A legacy data center is connected. The end devices are connected. The physical and the VMs are connected. Right? We got different physical and VMs. We have IPS, we have firewall, we have load balancer. We have another physical and VMM domain for apps, SQL database. And so these controllers are connected to the same place where the end devices are connected, the user space. But EPIC and the user space, they are not the same. EPIC's a controller. The user are the one which is going to use this ACI fabric. Now, if any user wants to go to internet, they go out via this way. If anyone wants to have a WAN connection through MPLS, they get routed through this way. So you do not need to compromise on anything. Everything that you used to have in a classical data center, you have it here. But the big difference is you're abiding into the framework of leaf and spine. This EPIC, this EPIC is coming in different series. M3 series, M4 server, M5 series servers. Different version like first generation, second generation, third generation, all M3, M3. If you say M3, they're first generation EPIC. M4 is second generation. M5 is third generation EPIC. Okay. Now why three epics? It is because the failure of epic, failure of one epic will not bring down the ACI fabric. How? The database between this epic is always shared. It's a shared database. So when anything is need to be saved here, it is actually made of three copies, and it gets saved also simultaneously on the other two epics. When you put some configuration on one, the other two also gets the same configuration parallelly. So every set of information is going to be of three copies, and this three copy get distributed between these three controllers. Now, if you want this epic to be operational, you need more than half of the actual size of the cluster. What is the cluster size here? 3. If one epic goes down, no problem. You can still write to the epic database. You can write the instructions. You can write the policies. You can write the informations to the epic. But if both the epics are gone, you have 3 epics, and ACI knows that you have 3 epics, but 2 epics have gone down. With one epic, you cannot write anything. It will be a read only. Why? I said EPIC is a shared database. In order to write to the database, minimum 2 EPIC is needed. Minimum. If you have 3 EPIC in the cluster, minimum 2 is necessary in order to write to the EPIC's database. Minimum 2. That's what I said. More than half. If you have 3 controllers, then 2 must be available all the time in order to perform the right operation. If one goes down, no problem. You can write, you can read. But if 2 epic goes down, the state of the epic will fall to read only. You can only read, you cannot write. Because at any given point of time, 2 copies must be present. 2 copies. If only one epic is there in a cluster, not possible. See, I told you in the beginning you can even have one epic to control ACI, but that is one. Initially, you have defined it as one. But when you have defined it as 3 in the cluster, after defining 3, if you have only one epic, it's not going to work. If you have said my epic is a cluster of 3, then you should have at least 2 APIC. If you would have said that I have only 1 APIC, then you don't have any problem. You can write, you can read from that 1 APIC. But Cisco recommends you to at least have 3 APIC. So in short, what I want you to remember is, in order to write the information into the APIC's database, we must have more than half of the APIC size. Half, more than half. If you have 3, more than half is what? 2 APIC. Do you have any question on APIC now?
No, sir, I don't have. But what is the current EPIC we are using it? Is it the third generation EPIC we are using it?
All right. See, the latest one we have to check with the document. Let me quickly check it first. See, the latest, the third generation is M3 or L3. But when you talk about the UCS server, in UCS server it is M5 server. I repeat, this M3 runs on a UCS server, Cisco's UCS server. If it is a physical, look at this, here it is written. This APIC appliance comprises either a cluster or Cisco APIC M3 and L3 third generation appliance. M3 or L3 third generation appliance. Cisco UCS 220 M4 second generation appliance. Cisco UCS M3 is first generation appliance. This is what I meant actually. I said first generation is M3. What I meant is this UCS server. First generation is M3. Second generation is M4. And third generation, I said M5, it is not mentioned here. That's the M5 version of UCS 220. That's the third generation. That is where you will have either medium third generation EPIC or a large third generation EPIC. But the server is M4 server. Here they're not talking much about server. Here they're only talking about the generation of EPIC. First generation, you call it as M1. But it runs on which server? M3. நான் சொன்னது புரிஞ்சுதா இல்லைங்களா? ரெண்டுத்திலையும் கன்ஃபியூஸ் ஆயிடக்கூடாது. நான் திருப்பி சொல்லட்டுமா? பாருங்க, ஃபர்ஸ்ட் ஜெனரேஷன் அப்ளையன்ஸ் பார்த்தீங்கன்னா எபிக் கிளஸ்டர் M1 L1. ஆனால் அது ரன் ஆகிற சர்வர், இஃப் யூ சி த சர்வர் இன் விச் இட் ரன்ஸ், it is M3. So we should not get confused with this M and that M. That M talks about the generation of EPIC. This M talks about the generation of UCS server in which the first generation runs. M1 runs on this. M1 runs on UCS 220 M3. M2 runs on UCS 220 M4. Second generation M2 then. Right? And then the second generation. Third generation runs on UCS 220 M5 server. They have not mentioned here. I have taken from another document, M5. All right, according to APIC, it is M3 or L3. All right. So, what is the next question that you asked?
I have asked about Epic, how it is changing, knowing each other.
Okay, the synchronization, right? The data sharing.
Yes, yes,
Data sharing, what protocol it uses? That's what your question.
first, yes, yes.
Okay. That we'll see in this document. So the answer to your question is it is Cisco OpenFlex, which is used to write and read to the APIC database. The second question that you asked is about the versions, the generation. The third generation, M3 or L3, is written into UCS C20 M5 servers. The second generation, M2 or L2, is written into C20 M4 server. Those things we saw here in this page. This page here it is written. First generation M1 or L1, and if you go down or go up, you can see the first generation is written into the M1 or L1 is written into Cisco UCS 20 M3 server. Second generation, which is M2 or L2, is written into M4 of UCS. Likewise, the third generation is written to M4, sorry, M5. Though they have not mentioned, that is actually M5. M3 or L3 is written into Cisco UCS 220 M5. All right. So that's about APIC. For now, that's about APIC. So whenever APIC writes an information, it's going to be three copies. It's going to be three copies. At least two of the APIC should be present in order to write. This is called quorum, Quorum. Now spine. When we talk about spine switches, this is going to act like a route reflector. If you have done any BGP class, you might have heard about route reflector. This acts like a route reflector. The spines are used to exchange routing information between the leaf switches using ISIS protocol. So the route information about these connected devices are learned in the leaf that gets distributed to the other leaves through the spine. So it is just like in route reflector. Now to provide this route information about the endpoints, it uses a protocol called COOPS. COOP. So it is via the COOP the information about the devices, the endpoints connected to the leaves are getting distributed. COOP. So it's Council of Oracle protocol, which is going to distribute the information about the endpoints between the switches. But who is going to distribute it? It is going to be, it's done by spine. So spine uses the COOPs to exchange the routing information between the leaf, and this route exchange using COOPs, that is right, COOP is involved in providing the information about the endpoint, but the routing protocol that is involved in distributing the root is ISIS. See, these two work together. COOP, Council of Oracle Protocols, job is to take the information about the endpoints and give it to ISIS, and it is ISIS the one which carries to other leaves. So about the endpoint, it is COOP. This collected COOP informations are distributed, exchanged to all other leaves. The information collected in one leaf is exchanged to all other leaves via ISIS by this spine. So spine works like a RR, route reflector, for all the leaves. Now external routes, meaning the routes coming from MPLS, routes coming from internet, those things are exchanged between the switches by the spine using MPBGP. So there are two protocols here we are seeing. One is ISIS, that is for local routing information. For the external routes, the distribution of external routes into the fabric is using the MPBGP, multi-protocol BGP. So this is the control plane for external route, this is the control plane for internal. The next is leaf. Do you have any question on spine?
No question.
So in short, spine is acting as an RR. It distributes the route information. COOPS, Council of Oracle Protocol, discover the endpoint host information, and that information is distributed by the spine using the protocol ISIS. The route information for external routes are distributed among the leaf using MPBGP by the spine, multi-protocol BGP by the spine. Now leaf switches is where the servers, you see we have physical server, we have VMM server, we have end user host, we have the other existing database connected. Actually, we call these as domains. Various type of domains are connected to the leaf only. We don't connect to spine. The servers, the external devices like routers, switches, they're all connected to this leaf. Not only routers and switches and computers and servers, even the APIC will also connect only to leaf. We saw that earlier. APIC is also, the controller is also connected to leaf only, not to any spine. Plus, because every device connects to leaf, all authentication, all security policies, they're all implemented in the leaf switches only. So this is a very nice interview question. Where is the security policies implemented in ACI? Answer is leaf, not spine. It's only the leaf. All right, so there are various type of leaves, border leaves, which connects to the external domain servers like this. This is a border leaf. There is compute leaf, the one which connects to the server. Service leaf, The one which connects to the firewall and load balancer, these are all service leaf. All right. So border leaf, compute leaf. This is a border leaf because it connects to the internet, MPLS. And this is also a service leaf because it is connecting to application, SQL service, IAPS, the firewall service, load balancer service, etc. Now, when you talk about leaf or spine, both are 9000 series switches, Nexus 9000 series switches. Now, when you take Nexus 9000, it comes in two modes, ACI mode as well as NX mode, Nexus mode. So we have 9500 series and 9300 series. Mostly all spines are 9500 series and all leaves are 9300 series. Mostly. But there is also one particular 9300 series which can be used as a spine. Right, as I said, this Nexus 9000 series can be a Nexus switch or it can be an ACI leaf or spine, but it cannot be both. Cannot be both. You cannot have Nexus switch mode as well as the ACI mode. Any one. Right. So if you just Google like a Cisco ACI scalability guide, you will find this information in detail. Right. So I think we will stop here for. If you have two APIC, then it will be allowing you to write less than two, means less than half of the cluster size. It will switch to read only mode. Okay.